Today we are covering attention complexity. Why long context is expensive. The goal is not to memorize a slogan. The goal is to build an interview-ready explanation that moves from intuition, to mechanics, to trade-offs, and then to a concrete example. Intuition. Full self-attention compares every token with every other token. That all pairs interaction is powerful, but memory and compute grow roughly with the square of sequence length. If you remember only one thing, remember the shape of the problem. Raw information is transformed into a representation that makes the next decision easier. Core mechanics. For n tokens, attention scores form an n by n matrix. Doubling context can roughly quadruple attention score work. KV cache helps generation but stores keys and values for past tokens. Long context increases memory pressure and latency. Efficient attention methods reduce, approximate, or structure the comparisons. The compact mental model is, attention score matrix size is almost equal to n superscript 2. Do not rush past the symbols. In an interview, define each part in plain language before you talk about implementation. That makes you sound like you understand the system, not like you only memorize notation. Common traps. Do not say long context is free because models support it. KV cache saves recomputation but consumes memory. Quadratic attention is not the only cost, but it is a major bottleneck. Sparse, sliding window, and linear methods trade exactness for efficiency. Concrete example. A 1000 token prompt creates about 1 million pairwise attention scores per head. A 10,000 token prompt creates about 100 million. That is why context length changes serving cost so quickly. Walk through the example slowly. Say what changes at each step, what stays fixed, and why the operation helps the model produce a better representation. Interview checklist. State the n by n matrix clearly. Give doubling context example. Explain compute versus memory pressure. Mention KV cache separately. Name efficient attention families. A strong final answer for attention complexity should have 4 beats. First, give the intuition. Second, name the components. Third, describe the formula or data flow. Fourth, mention the trade-off. If you can add one example, you will usually sound much more practical than someone who only gives a textbook definition. Now let us rehearse the answer in a more conversational way. Start broad. What problem are we solving, and why did this idea become useful in modern AI systems? Then narrow down, what data structure or tensor is being manipulated? Then explain the operation, what is multiplied, normalized, added, masked, or learned. Finally, connect it to behavior, faster training, better context, more stable gradients, lower memory cost, or clearer generalization. For interview practice, avoid 3 mistakes. Do not give only math without intuition. Do not give only intuition without naming the mechanism. And do not pretend there is no trade-off. Most AI interview questions are really trade-off questions wearing a concept label. The best answer shows you know when the method works, when it becomes expensive, and how engineers usually manage that cost. Quick recap: attention complexity. Why long context is expensive. Use the mental model, define the pieces, give the example, and close with the practical trade-off. That is the answer structure to keep in your head. One more interview rehearsal. Explain it as if teaching a teammate. Define the input, describe the transformation, name the output, and close with why the design choice matters in real systems. This habit turns a memorized answer into a practical engineering answer.